Let us again look at the standard equation of hyperbola. For the sake of this video, we're just going to look at the role of Q. So we will consider P equal to 0. So we will not do any horizontal shifts or look at P equal to a number other than 0. Let us do the algebra first. I've just included the theory of the mother graph, the green graph, and in this case our k equal to 1 is positive, so we're in the first here and here, first and the third quadrant. This is where my parabola will be. I have 1 over x and I have the domain and the range and the asymptotes, etc., and the lines of symmetry. Now let us look at the function y equal to 1 over x plus 2. First of all, I know that I cannot divide by 0, so x may not be 0. So in the domain I will have x may not be 0. So what can we now not have? Again, this 1 over x here cannot be 0. So I will not be able to have any y value that can become 2. So in this case, my vertical asymptote is x equal to 0 and my horizontal asymptote is y equal to 2. My lines of symmetry, y equal to plus x, and because of the q there, I will have plus x and minus x, but I must add the plus 2 and the plus 2 there. So I simply add the q value to my two regular 3 lines of symmetry. So I have y equal to x plus the q value, and I have y equal to minus x plus the q value. The red graph is then the green graph shifted 2 units upwards because my q value is equal to 2 and that is positive, so I will shift up. So let us look at our graph. This is y equal to 1 over x and y equal to 1 over x. And this is y equal to x and this is y equal to minus x. When I add this 2 here, that means every y value that I have must be added 2 units. So it is 1, 2 units up. If I take a value here, it's difficult to measure it, but it's 2 units. The distance between the two graphs are 2 units. And it doesn't matter, it looks as if it goes very near each other, but the distance stays 2 units. Doesn't matter where you go, the distance is still 2 units. If I look from here to there, it shifted 2 units up. So what happens to the axis of symmetry? Here I have my y equal to x. That also shifted 2 units up. This is now y equal to x plus 2. Shifted 2 units up. And my other one is minus x. So that also shifted 2 units up. And that becomes y equal to minus x plus 2, like we said before. Let us calculate the coordinates of the vertices. If I look at the vertices, since k is positive, I have in the first and the third quadrant. To find the vertices, I must see where y equal to x plus 2 and y equal to 1 over x plus 2, where they will intercept. So I have to solve x plus 2 equal to 1 over x plus 2. If I do that, x may not be 0, so I can multiply both sides with x. So I get x squared plus 2x is equal to 1 plus 2x. So that gives me x squared equal to 1. Because I can cancel that. So therefore x is equal to plus or minus 1. So if x is equal to 1, then y is equal to 1 plus 2, which is 3, and if x is equal to minus 1, then y is equal to minus 1 plus 2, which is equal to plus 1. Then we can also look at the x-intercept. This is where y is equal to 0. So now I have to use this y equal to 1 over x plus 2. And so I have to solve 0 equal to 1 over x plus 2. That means I can multiply by x again. Then I get 0 is equal to 1 plus 2x. So x is equal to negative a half. So that's my x-intercept. So what is my y-intercept? This is where x is equal to 0. But we know that y equal to 1 over x plus 2 is undefined. So x is not part of the domain, so there's no y-intercept. So let us look at the graph. Remember that we have already said what the vertices were. So this is my minus 1, 1, and that was D. And the other one, C, which is 1, 3. So here we have the x-intercept is minus a half there, and this is our vertices D, minus 1, 1, and C, 1, 3. So algebraically, we've also confirmed what is shown on the graph here. For p equal to 0 and k positive and q positive, then our hyperbola shifts vertically q units upwards, so the horizontal asymptotes shift upwards as well, and the two axes of symmetry shift with the graph.